How's it going, ladies and gentlemen? Mr. Johnny here. We're going to take a look at using solubility curves. So you probably want your reference tables, and what we're going to cover is reading the chart, so how to use these curves. We're going to look at some vocab, again, saturated, unsaturated, and supersaturated. We're going to talk about using the chart to answer some problems, and then we're going to talk about special conditions, using the chart to answer some problems where things are a little different. So first thing, let's take a look at reading the chart. As always, you should always look at the X and Y axis first. So x-axis, we got temperature, and then y-axis, we got solubility, specifically how many grams of solute can be dissolved in 100 grams of water. Now you may be asking, what's with the 100 grams of water? Well, the more water you use, the more solute you can dissolve. That should kind of make sense. If you have a teaspoon of water versus a gallon of water, those two things are going to dissolve the amount of salt differently. You can dissolve more salt in a gallon of water than you can a teaspoon. So they specified how much water, just because they had to pick one. 100 grams, that's a nice round number. So question here is, why does some go up and others go down? So if you take a look, for example, NaNO3, that one goes up as temperature increases. But if you take a look at like HCl, it goes down as temperature increases. So let's think about this. If it looks like this, well, what kind of solutes increase solubility as temperature goes up? Solids. All right, well, what solutes decrease in solubility as temperature goes up? Gases. So if you take a look, there's a lot of solids. Let's find the gases. Well, HCl is one, because it goes down as temperature increases. Whatever this line is, NH3, that's another one. And then SO2 is another one. So there's three gases on this chart. The rest of them are solids. So saturated, unsaturated, and supersaturated. Let's take a look at just one line. So I'm going to take a look at this line right here because it's kind of in the middle. So let's take a look at the NaNO3 line. All right. This is showing you the saturated line. It's showing you how much stuff, how much solute can dissolve at a given temperature. So if we're below the line, if we're right here, what's that telling us? Well, it's telling us we can have more solute in it. It can have up to this much at that temperature. So if it's below the line, we call it unsaturated. All right, well, if it's on the line, what's that mean? If it's on the line, then it's saturated. It's saying, hey, you have exactly the amount of stuff that can be dissolved at that temperature. And if it's above the line, well, what's that mean again? Above the line means we have more in there than we should be able to, and we call that supersaturated. So below the line, unsaturated, on the line, saturated, and above the line, supersaturated. So using the chart. Here's an example question. It says, how many grams of NaNO3 are needed to make a saturated solution in 100 grams of water at that temperature? So remember, the 100 grams of water is just saying, hey, use the chart exactly how it is, because the chart is for how much will dissolve in 100 grams of water. So this 100 is just telling you, just use this chart exactly how it is. So you could look, all right, 30 degrees Celsius, you find that on the chart, and you go up till you find NaNO3. So I found the NaNO3 line right here. So I'm looking at this line, 30 degrees. I just follow it up till I hit that line. It's right about here. And I look over, all right, well, how much is that? Well, I know it goes from 90 to 100 in one box. It's not quite to 100. It's a little more than halfway. I'd probably call that 98 grams of NaNO3. That's how much you would need to make a saturated solution in 100 grams of water at that temperature. So same kind of question, just a little different. So here it says the same thing. How many grams of NaNO3 are needed to make a saturated solution in 50 grams of water at the same temperature? So we said we needed 98 grams in 100 grams of water. Right? This 50 grams of water doesn't match our chart. Our chart is for 100 grams of water. But let's think about this. If I used half as much water, then I can only dissolve half as much stuff. So I got to take 98, divide by 2. Then I get 49 grams. So because I used half the amount of solvent, I can only dissolve half the amount of solute. If it was twice as much, then I could dissolve twice as much. So what is the solubility of HCl in 100 grams of water? So HCl, 100 grams of water at 70 degrees Celsius. So let's find some of this stuff. Found HCl. It's this line right here. I got to find 70 degrees Celsius. And what's that 100 grams of water telling me again? It's telling me that I don't have to do anything with my answer afterwards. It's exactly what's on the chart. 100 grams of water, how much it dissolves. So I follow 70 degrees line up. I hit the HCl line right about there. I follow it over, and it's a little more than 50. I'd probably say that's like 52 grams, 51 grams, give or take. What kind of solution do you have if 80 grams of KClO3, so let's find that KClO3, found it, are dissolved in 100 grams of water, so that's just right off of my chart, so I can use the chart as is, at 40 degrees Celsius. So 40 degrees Celsius. All right, well, what's this 80 grams telling me? It's telling me how much of my solute. So 80 grams, all right, at 40 degrees Celsius. So I find where those two things intersect. I go across 80, 40, so I'm right here. That is my point. And KClO3 is this line way down here. So it's asking what kind of solution do we got? Well, I got my point way above the line. So it's above the line. So what's that tell me? Is it unsaturated, saturated, or supersaturated? Well, above the line means we have more than we're supposed to be able to. We should only have like 16 grams. We got 80. So that is definitely a supersaturated kind of solution. What is the solubility of HCl? So let's find HCl again. Bam, found it. In 100 grams of water, which tells me I just use exactly the chart. I don't have to do anything with it afterwards. At 70 degrees Celsius. So I find that 70 degrees Celsius. I go up till I hit the HCl line right there, and then I go over, and it's a little more than 50. I'd probably call that, again, 52 grams. And that would be its solubility. All right, so I hope you found that helpful. Get some practice in with this stuff, and I'll see you in class.